my space. In today's video, we shall be looking at the inverse variation. Now, the inverse variation talks about two parameters. One is increasing, the other is decreasing. So y could be increasing, while x is decreasing. So it runs inversely. For example, let's say if y is varies inversely as x, so we use 1 over x. Introducing a mathematical constant, y is equal to k times 1 over x, which simply means y is equal to k over x. So k will be equal to yx. So this is a simple expression in finding the mathematical constant or the constant of variation. So how do we apply this to solving problem? Let's take an example. We have an example here. It says, given that P varies inversely as 1 over root r, and P is equal to 3 when r equals 16. Find the value of r when P equals 3 over 2. So let's look at this problem. First of all, it is an inverse variation. So the expression goes solution. We have P to be inversely proportional to 1 over root r. So that means P is equal to, I introduce my constant of variation k all over square root of r. So what does it mean? We are told that P is equal to 3. So when P equals 3, we have r to be equal to 16. R is 16. So we simply substitute to find k. So P is 3. So we have 3 to be equal to k all over square root of r is 16. So that means we have 3 to be equal to k all over 4, because square root of 16 is 4. So from here we can say k is equal to 3 times 4, which is equal to 12. So k is equal to 12. Now we substitute the value of k into the expression. So we have it as P to be equal to k is 12 all over square root of r. Simple expression. Or we can still write it in this form: P root r is equal to 12. Now with these expressions, we can go ahead to finding the value of r when P equals 3 over 2. So when P equals 3 over 2, we are looking for r. R is unknown. Remember, we have obtained k to be equal to 12. So let's substitute into the expression to find r using the first or the other one. So we have P, which is 3 over 2. P is equal to 12, which is our value for k, divided by root r. So we cross multiply. So this takes this, we have 3 root r to be equal to 2 times 12. So root r is equal to 2 times 12 divided by 3. So 3 here is 1, 3 here is 4. So root r is equal to 8. So to find r, we square root both sides. So we square both sides. So it takes out the root. So r is equal to 8 times 8, which makes 64. Therefore, r equals 64. And this is a simple application of the inverse variation. Onto another example. It says P varies inversely as the square of W. First sentence, when W is 4, P equals 9. Second sentence, find P when W equals 9. Now, solution. Let's get started. The first sentence writes the expression, the variation. It says P varies inversely as the square of W. So I'm going to, this is my variation sign, 1 over the square of W simply means W square. So from here, if I introduce my constant, I'm going to get P to be equal to K all over W square. So from here, I can say K is equal to P W square. So take note of this equation. Now, the second sentence says when W equals 4, P is equal to 9. So we are going to substitute both into the expression to find K. So what does it mean? It means K will be equal to P is 9, 9 times W is 4, so I have 4 squared. That makes 9 times 16. So 16, 9, 6 times 9 is 54. Write 4 and carry 5. 9 times 1 is 9 plus 5 is 14. So we have 144. So K is equal to 144. That is the value of K. We can go ahead to substituting the value of K. So it means 144 is equal to PW squared. That is for second sentence. The value of K as 144 helps us to move to the third sentence. It says we should find P when W equals 9. Now, third sentence, when W equals 9, remember K is 144, so P will be equal to unknown. That is what we are looking for. So what we have 144 to be equal to P unknown, W is 9, so we have 9 squared times P. So 144 is equal to 81P. So divide both sides by 81, takes this, so P is equal to 144 divided by 81. What does that mean? You can see when I add 4 plus 1, it gives me 9. So that means 9 can divide 144. When I add 8 and 1, it gives me 9. So it means 9 can divide. So when 9 cancels 81 is 9. When 9 cancels 144, 9 into 14 is 1, remainder 5. 9 in 54 is about 6. So what else can go? Nothing can go. So we have P to be equal to 16 over 9, which is our final result. I'm sure this example on inverse variation is clear to us.